The law of exponential growth says the rate of change of y is directly proportional to y. Do you remember this lesson? And that is the lesson where we would write differential equations, equations that involve slope, based on the way they worded something. And often there would be some direct variation or proportional thing where we'd have a constant of proportionality. Let's use it. The rate of change of y with respect to, now I would say x, but most of these are going to be word problems that involve t for time, so I'm going to call it dy dt. They didn't say exactly, but the rate of change of y with respect to time is directly proportional to constant of proportionality, y itself. Write a differential equation, done, and solve it for y. So let's do that. We're going to get y on the left and t on the right. So in order to do that, we need to bring dt to the other side, and we need to get y over here. So we'll divide by y, and I've said this in a previous video, he said very slowly as he divided by y. The things that are around y, it's best, if possible, to keep them on the side that's not with y. So we're going to keep this k over here. It just complicates your life if you divide it by ky, k times y. We won't do that. So what we're going to do instead is just keep the k on the right side. We'll integrate this, we'll integrate that, and we have loud ink pens when we throw them down, don't we? The integral of k dt, the integral of some constant with respect to time would be that constant times time, and then plus c. So like if this was a 5, it'd be 5t plus c, or if it was a 10, it'd be 10t plus c. The integral on this side, well, the integral of something when you're dividing by a thing, a function, or y in this case, to the 1 power, would be natural log. There we go. And we built our c in on this side. So we're going to keep solving, and we encountered this on the previous lesson. I'll use green for this as well. If I want to e this side and e that side, and that's not the best way to word it, but basically e to the left equals e to the right, and that's not the only way to think about it. Basically, these two would cancel. If you want to think about it another way, you could just rewrite this in exponential form, and you would have e to the kt plus c equals y, and that's exactly what we're about to get. I'm just treating it like I'm doing the same thing to both sides. So e to the kt plus c, and then I'm going to continue. Now you're like, oh, I'm done. I've got y by itself. Yes, but remember this. Y equals e to the kt, and then e to the c. And then I would look at this and say, well, e to the c is just a constant. So we're going to treat it like the constant that it is. It's a number to a number, and that makes it a constant. We'll put it in the front. This is the law of exponential growth. So when you see the law of exponential growth in your problem, or the rate of change of something is proportional to that thing, the rate of change of the population is proportional to the population, this is the formula that you're going to use.